So now that you've tried number 6 and number 7 on your own, let's work them together. For number 6, before we can set up our two cases, we must add 1 to both sides. This has to be your first step, otherwise your answers will be incorrect. So if I add 1 to both sides, the absolute value of x plus 3 is less than 6. So now that everything on the left is isolated in absolute value, all I have on the left is inside the absolute value bars, I'm ready to make the cases. So only now can we make our cases. X plus 3 is less than 6. X plus 3 is greater than negative 6. And then the only thing we have to do to solve each one of these inequalities is subtract 3 on both sides. X is less than 3. X is greater than negative 9. So we don't have or equal to underneath our inequalities. So we will not use closed circles, we will use open circles. So if I put an open circle over 3 and I draw an arrow going to the numbers less than 3, it has to go to the left. If I draw an open circle over negative 9, and it has to be the numbers bigger than negative 9, I need the arrow to go to the right. So we see that these arrows are going together. So this is an and inequality. So the inequality with the smaller number, x greater than negative 9 is first. I put the word and in the middle, and x less than 3 goes second. For number 7, the operation that is happening between the 3 and the absolute value bar is multiplication. So we do not subtract 3 on both sides. To solve this one, we have to divide both sides by 3 to undo multiply by 3. So 3 divided by 3 cancels out. What we have left here, absolute value of 2x plus 8 is greater than or equal to 10. So now that we have everything over on the left side in absolute value, we can make our two cases. You can only make your two cases if everything on the left side is inside the absolute value bars. So we make our two cases, 2x plus 8 greater than or equal to 10, 2x plus 8 less than or equal to negative 10. To keep going, we need to subtract 8 from both sides of both inequalities. 2x is greater than or equal to 2, and 2x is less than or equal to negative 18. From here, to finish solving, we have to divide both sides of both inequalities by 2. So x is greater than or equal to 1, and x is less than or equal to negative 9. So we have or equal to underneath our inequality symbols. We're back to closed circles. If I put a closed circle over the number 1, and I want all of the numbers greater than or equal to 1, I need to draw the arrow going to the right. Negative 9 needs a closed circle over negative 9. If I want all the numbers less than or equal to negative 9, the arrow needs to go to the left. Notice that the two pieces of your graph are going apart from one another. When this happens, this means this is an or compound inequality. So inequality notation, we start with the inequality that has the lower number, x less than or equal to negative 9, or x greater than or equal to 1.